Good afternoon, ladies and gentlemen. Welcome to Physics 30. What lesson is this? 8? 7? Lesson 3. Oh, that's right. Lesson 3, radiation half-lives. Now, in Physics 30, we are concerned with the rate at which radioactive decay occurs. If you look at the periodic table, you'll note that there are many elements that are radioactive, that is, not stable, and they decay. This actually glows in the dark, but it's too bright for you to see. Life. Now, if we graph radioactive decay, we get our standard exponential graph like this. Now, a few things about this. One, it helps to have taken Math 30 logs and exponents section, but they've written the exam so that you don't absolutely have to take Math 30 before you take Physics 30. It does help. So, if you've taken Physics 30 and done logs and exponents, congratulations, this is easy. Now, the second thing is the formula they give you. Something like this. N sub 0, 1/2 to the t. This is the remaining. N sub 0 is what you started with. And t is number of half-lives. Now, half-time, or half-life, number of half-lives. Half-lives is, should write this down. Half-life Fe or V? Half-life. Fe. But if it's plural, it's lives, L-I-V-E-S. Yeah. All right. Half-life time for 1/2 the sample so reading it off the graph is easy. Whatever you start with is N sub 0. Half of that is your half-life. So if you start off with 100 grams, when you get to 50 grams, read it off, and that's your half-life. If you start with 1,000 grams, then half of that is 500 grams. Whenever you reach half of what you started with, that's your half-life. Now, test question like that, if this was like 8 days, then one of the options would be like 1 day. They would not go 7, 8, 9. I've never seen anything like that. They're not that picky. But you might have 8 and 12. Something like that. But it's close enough that there's only one number that works. Okay? So far, so good? Now, the other thing is this N, the nuclei. This could be the number of nuclei. Or it could be, that is, number of atoms. Or it could be the mass of whatever you're dealing with. Doesn't necessarily have to be the number of atoms. If you've done chemistry 30 or chemistry 20, you know about the moles. And usually we don't do moles in physics 30. We talk about mass. We also talk about percentage. So we'd start with 100%, and when we get to 50%, that's the time for our half-life. It can also be the activity. Now, this activity is usually measured as becquerels. BE. Sorry, I have to take a peek. BECQ. 1 BQ is 1 decay per second. So 1 alpha particle emitted per second or 1 gamma ray emitted per second is 1 becquerel. So they can talk about the activity. So you start at 50 becquerels. What's half of 50? 25. So whenever you reach 25 becquerels, that's your half-life. And what's half of a half-life? Well, you end up with a quarter of what you started with. All right? So when I say N, it could be number of nuclei, mass, percentage, or activity. That's all basically the same. If you're looking for half-life, find half of it. Now the other thing, if you guys have done math 30, then you know should actually be written something like this. A, B, T over P, or N equals N sub 0, 1/2 T over P, because N, the formula they give, they call this, wait, so I'm sorry, do they call this T or N in Physics 30? I forget. Look at your formula sheet. For exponential, for radioactive decay, they do give you this formula. May I? My apologies. Too many formulas to remember. Oh, they call it N. Poopy. I apologize, ladies and gentlemen.
The T should be in it?
This T should be a little n. So they use capital N sub 0, and little n. Ugh. So N is time divided by time of half-life. So if you've taken math 30, you know this should be T over P or T over X or whatever. So you can go time and time for a half-life. They simplify the equation and then they don't, just to confuse you. Welcome to my world. Anyway. Now, this time, the half-life, is time for half the element to decay. So now, half-life varies. Polonium 214 has a half-life of 1.64 times 10 to the minus 4 seconds. That's really rather short-lived. That's something made in a nuclear reactor that's quite unstable and breaks up pretty quickly. Krypton 89. Another byproduct of nuclear reaction has a half-life of 3.16 minutes. Carbon 14's 370 years, something like this. That's not a bad half-life. Iodine 115, on the other hand, is 4.41 times 10 to the 14 years. So if you get something irradiated or covered with iodine 115, leave it. Just walk away. It's going to glow in the dark forever. So half-lives, you cannot look at an element and tell what the half-life is. That's something you have to measure or be told. You can read it off the graph. Now, so far so good? All right, let's do some example questions. And I'll show you why you don't need the log section from Math 30 to do this. So, radon 222, half-life, 3.83 days. So, after a year, capitalize because I'm making a new sentence. how many half-lives have passed? Well, one half-life is 3.83 days. Two half-lives would be 7.66 days. Three half-lives is 10. Unit conversion. How many days in a year? Times one half-life divided by 3.83 days. Spread out the number you want. Divide by the units you started with, multiply by the units you want, half-life. And how are they related? One half-life is 3.83 days. Multiply that out, and what do you get? I got 95.3 half-lives. And I think I'm going to go back and change this to 1. Write out the half instead of as a fraction, otherwise too many numbers to confuse people. So one half-life is 3.83 days, so I get 95.3 half-lives in a year. Am I correct? All right. So if you started off with 10 milligrams, what was it, radon?
Yeah.
RA222. How much do you have after a year? Well, that's a question, not a statement. So, we start off with 10 milligrams. Now, we got to do some math. And I've got to erase that little boo-boo because that drives me insane. No, sorry. They've got it there. There's the eraser. They change this every year. Now, what's the formula?
N times 1/2. Yeah, squared.
To the end. N equals n to the 1/2 to the n. Not the best move on their part, but no, pardon me, no comment. So, you started with 10 milligrams. Now, those of you that have taken Math 30 are going, this is 365 days. Let's color code that. Divided by the half-life, 3.83, but that's 95.3 half-lives. The time is 365 days, divided by the time for a half-life, 3.83. We figured that out earlier, 95.3. So we can just plug that number in. What are you getting? 10 times 1/2 to the 95.3 is what? Come on.
2.05.
Okay, let's not convert to kilograms yet, but thank you. What was it originally? Milligrams? It was? Charles, what'd you get? I got 10 to the minus 28 milligrams. When I did it, I got 10 to the minus 28 milligrams.
Yeah.
Now, here, I want to point out, two things. I hate this. It won't go away. Secondly, units. You're right, Lloyd. We don't go minus 28 milligrams. We change that to grams or kilograms. Now, that is 2.7. Okay, so there's 1,000 milligrams in a gram. So this is 2.07 times 10 to the minus 31 of a gram, I think. And that is 2.07 times 10 to the minus 33 of a kilogram.
Oh, sorry.
I think. Now, they would probably put this in grams. I expect the answer in grams. They might put it in milligrams, but as I said, to the minus 28 of a milligram is not a standard unit. At this point, we'd probably turn it into grams. So be careful about that, because how are they going to be poo heads? Give you a question in milligrams and expect the answer in grams. Yes, I said poopy heads. Okay, so a question for you. I have no idea what's going on. Go away. Leave me alone. All right, so another question, or another version of question you see on the diploma. Half-life of strontium. One of the isotopes of strontium has a half-life of 28.5 years. What percent means AFT here? 100 years. Come on, guys, I want to get this done.
We just do 28 divided by 100.
Careful. N sub 0, 1/2 to the n, or n sub 0, t over p. So, what percent remains after 100 years? How much do you start with? What percent would you start with? 100%. Times 1/2. The time we're looking at is 100 years. The time for a half-life is 28.5. So you guys plug those numbers into Mr. Calculator and tell me. Eight point. 100 times 1/2. That's to 28. That goes into 100 almost 4 times. So that's a half of a half of a half of a half. 50%, 25, 12 and a half.
Yeah, I mixed up my.
Yeah. Don't do that. And it's not 28 divided by 100.
Yes.
Come on. Standing here looking heavy on the camera.
Yeah, 8.7.
8.7 what?
8.78.
8.78, 8.79%, something like that. Okay. Typical question. All right, now do you want me to show you the hard one they'll put on the diploma?
Sure.
No, but what the hell? I'm going to show you anyway because I'm evil like that. Charlize isn't here, so. The activity Magnesium 18 is initially 28 BQ becquerels, 28 reactions per second. Eight hours later, the activity is 18 becquerels. That was interesting. Don't randomly change colors on the bed. Is 18 becquerels. What is the half-life of Charlesium 18? Now, how do we find this? Where are the red dots coming from? Whatever. Okay.
I have to do logs.
Yep. No, you don't have to. Remember I said in this course, they want you to take Math 30 first. But, of course, in some schools with scheduling, they'll do Physics 30 before they do Math 30. So they've changed that. So they changed this part of the curriculum. You don't have to do Math 30 anymore. N equals N sub 0, 1/2 N. So what are we looking for? We're looking for the P, the half-life. I've given you the time, 8 hours. I've given you the initial amount, 28, and I've given you the final amount, 18. You can graph that. Y1 is 18. Y2 is 28 to 1/2 to the 8 divided by x. So the half-life, I don't know, something like 10 hours. Like, graph it and tell me what it is.
Yeah, but yeah, we can do logs though.
I'll show you in a minute how to do logs.
So it's not recommended for us to do logs.
Don't have to. Like I said, I know you guys have done Math 30 logs. I taught it to you. But what about next year? Perhaps the Physics 30 will be in the fall and Math 30 will be in the spring. So you solve this graphically. That'll give you a decimal approximation. Frankly, I'm okay with that.
20.5 cents.
No. I got 12.55. Now, as I said, graphing this, if you're going to solve it up, come on. I said next page. It shouldn't matter. Wait a minute. 18 equals 28, 1/2 8 over x. Now, if you're a mathy person and you really want to solve it algebraically, divide both sides by 28, you get 18 over 28 equals 1/2 8 to the x power. That's 9 over 14. And then turn log. Log base 1/2 of, thank you, 9 over 14 equals 8 over x. Thank you. Yes, then we do switch this, so x equals 8 over log base 1/2 of 9/14. You plug that in Mr. Calculator, you should get 12.55. Now, I was also going to say, you've got a base, if you have an old calculator where you can't change the base, this is 8 log of 1/2 divided by log of 9/14. Changing bases on your calculator. I have no idea. May I? 8 divided by x, that looks good. Windows 0 to 20.
We just find when y equals
0 to 30. Graph. You get something like that. Okay. See if the camera can pick that up. Good. That's your log. Yes, that's a typical log. And then the second one is 18. There we go. And calculate the intersect. It should be 12.55. Like I said, if you know how to do the log stuff, do the log stuff. But honestly, they're going to go to one decimal place, so graphing is good enough, and probably quicker. As long as you put it in the graph, as long as you put it in the equation correctly. So you've got the time, double check it, because poop happens. Now, that's pretty much it. I just want to point out a couple things about the homework. No, sorry. Now, with the homework, it's a bunch of typical diploma questions. Draw a graph. Draw a crude graph. I was going to say, yes. You could, on the old diploma, they'd occasionally give you a graph. You have to find the half-life from that. Now, you choose the correct answer. Now, quite often, use this information to answer the next two questions. So you take this answer and plug it in and use it in this question. If you cannot, note the wording. You can receive marks for this question even if the previous question was answered incorrectly. This was popular on the older diploma. I don't know about the new diploma, but I do know if you didn't know and you guessed and got it wrong, as long as you use that number, say, I know what the correct number is, say you chose 24, that's the wrong answer, by the way, and if you chose 24 here and you use that in your calculation, you would get a certain number. They would give you credit for this for doing the calculation correctly, even though you used the wrong input.
I think I saw that in the math diploma. They used the same one for this question.
Okay.
I think it was during trig.
Possibly. I don't recall. Anyway, another one. Read the graph. Find the half-life. All right. So I don't know if you've seen that before, but use one answer for the next one, and if you make a mistake in the first one, you can still use it and get credit in the second. All right. Go for it.